In this video, we will discuss insertion of a node between two nodes. There are two subcases: insertion of a new node after a node and insertion of a new node before a node. First, let us look at insertion of a new node after a node. To insert a new node, first we need to find a reference to the node that has the after value. To do that, we traverse the linked list. We set current to the first node in the linked list by executing the statement current equal to head. Current is not equal to null as current refers to this node. So we enter the while loop. We check if current.info, which is 13, is equal to 28. It is not equal to 28, so the if block is not executed. Next, current equals current.next is executed, by which current refers to the next node in the linked list. Current is not null as it refers to this node 28. Current.info, which is 28, is equal to the after value, which is 28. As a result, the break is executed and we break out of the while loop. Since current is not null as it refers to this node, this if block is not executed. Now we create a new node. We set its data member info to 30. We set its data member next to the node which current.next refers to. Current.next refers to this node 7. So we set new node.next to this node 7. Finally, we set current.next to the new node. This is how insertion of a new node is done after a given node. Let us implement the code in the Eclipse IDE. Insert after node method takes in two parameters, after value and new value, both of type int. We declare a local variable current of type node and initialize it to head. So now current refers to the first node in the linked list. While current is not equal to null, we check if the info of current equals the after value. If it is so, then we break out of the while loop. Else, we set current equal to current.next, by which we make current refer to the next node in the single linked list. Once we are out of the while loop, we check if current equals null. If current is null, we return. Current is null in two cases. One, when the linked list is empty, and the second case would occur when there is no node with its info data member equal to after value. If we do find a node with an after value as its info, then we create a new node instance in the heap. We set its data member info to the new value that is passed in. We set its data member next to the node which next data member of current refers to. And finally, we set the data member next of current to the new node. As you see here, the traversal of the linked list from lines 86 through 92 is quite similar to the find method. So we can refactor this block of code. So instead of this block of code, we could have node current equals find of after value. So this is the implementation of the insert after node method.